Hello, everyone, and welcome to Space Cat Code. My name is Quinton. I'm a senior software engineer with around 10 years of programming experience, and I'm super excited today because I'm going to be refactoring a rock, paper, scissors application. The original video for this code, like where we actually wrote this code, can be found in the description below. This is pulled from Codecademy, so in that video you can see us actually write this code out in the Codecademy editor. And I thought it'd be super interesting to just see how I would go about refactoring this if a more junior engineer brought this code to me in a code review, or if they wanted to pair program, or whatever, in order to just get my advice on the code maintainability or just where to go next, testability, that kind of thing. So you can see here I have two windows open. On the left hand side, this is the original code. So I literally just pulled this from the Codecademy editor and pasted it into this text editor. On the right hand side is a test suite that I created in order to make sure that the code is working, and as we refactor things, it's still working. Because even though this video isn't specifically about testing, I truly cannot actually just go in and start refactoring some code without writing a couple tests beforehand, because otherwise you don't know if what you're doing is actually working. How else would you know? I would just have to come here and play the game myself, manually using every single input. Writing tests make it so much easier to understand if what you're doing is actually breaking the code or not. So this is what we'll be using to see whether or not our refactors work. Even though this video is not about testing, testing is truly a fundamental part of the programming lifecycle, because without this, we don't have any confidence that what we're doing is actually beneficial. So on the right hand side here, I've written a couple of tests, and there's not too many because there are a finite number of options in a rock, paper, scissors game. There's only two players, and you can either pick rock, paper, or scissors. So I've just gone ahead and written out every single possible outcome. So paper versus paper, rock versus paper, scissors versus paper. So basically every different combination. These are the paper tests, these are the rock tests, the scissors tests. And then also we have a secret input of bomb. So if the user picks bomb, then the user will always win. So we want to make sure that that still works. And then finally, we want to make sure that if we input something ridiculous, some random, string of nonsense, we want to make sure that we get an error thrown. Now, what I've done, because the computer choice, so how I mentioned there's two actual players. In this version of rock, paper, scissors, we have a user and a computer. And that computer can either just randomly generate rock, paper, or scissors. Now, randomness is very hard to test for obvious reasons, because every time you run it, you're going to get something random. That's unpredictable, and that's unpredictability is hard to test. So what I've done is I just thought, well, we can probably just refactor this so that this can take two inputs and we can just manually pass these, and then that is how we can test this. But separately, we're going to have to test the get computer choice, because if we're passing a secondary input, then we're not going to call computer choice. So we do want to make sure we're still testing get computer choice. And what I've done down here is I've just written a really basic regular expression that just says, hey, make sure that this string matches either rock, paper, or scissors. And there's probably a better way to do this programmatically so that we run this 100 times or something, but I've just manually typed it out 5 times. It's just a little sanity check. Hey, make sure we call this 5 times, and every, of those 5 times, make sure we always get rock, paper, or scissors. I think if that passes, we can be pretty confident that this is still working. So I already know that we need to make play game take 2 inputs. So I'm going to go ahead and fix that now. So I'm just going to say user input and computer input. Now we have this hard-coded as bomb currently, so I'm going to replace bomb with user input. And then computer input, that's what the computer choice is going to be. If we don't pass it a computer input, though, we want it to generate a random input. So I'm going to pass that there as a default. Okay, and then we want to use that down here as well. Let's go ahead and run these tests to see what we get. Okay, so get user choice, user input equals user input to lowercase. Oh, okay, because we're calling it here. because yeah, I just literally copied this from the Codecademy editor, so we were calling that there, so that makes sense. So let's just get rid of that and run these again. Okay, so get computer choice is not a function, and so play game is not a function. This also has to do with the fact that I just copied it from Codecademy. You can see here in this file, we're not exporting any functions. So this line here, these are undefined. There's nothing that we're exporting, which makes total sense since in Codecademy, you didn't really need to. But in order to fix that, we can just write, let me get that on the screen here, module.exports, and we want to export play game and get computer choice. Those are the two that we're interested in testing. So if we run that again, okay, now the tests are actually running, which is good. That's a step in the right direction. But you can see here that we're expecting these strings, but we're always getting undefined. That also has to do with the fact that within Codecademy, we were just console logging. Now we actually want to return a value to make it a little bit more testable, having like your input output. So instead of console log, we are just going to, oh, whoops, need to put that D back. Now we're going to be returning the value, and let's see what we get now. And there we go. Bam. All the tests are passing except for one, which has to do with throwing if a unsupported argument is passed, which is fine. I think in the code here, yeah, we're just console logging instead of throwing, which is totally fine, you know, within Codecademy. But just for the sake of this, I think it's a little bit better if we throw an error. So let's do that for our very first refactor here. So if we look at this get user choice function, let's look at what it's actually doing. So it's taking user input, it's lowercasing it so that we can check against a couple values. And if any of these values match up with what user input is, then we return user input. Else, we console log like an error. So actually what this is doing is it's validating input. It really doesn't have to do like, this doesn't really have anything specific to do with the user. This is just validating a rock, paper, scissors input. So I think what we can do here is we can actually say like is valid input. And then here we can say, we can just call this input because it's not, again, you know, it's not really, it doesn't really have anything to do with the user. So then if we rename these input, when you have a, you know, a validation function like this and you prefix it with is, that almost always signifies that this is going to return true or false. You're basically asking it a question and you want to have true or false returned. So I think what we could do actually is we could say like, you know, valid inputs, which is rock, scissors, whoops, paper, or bomb. And we can just say if the input is one of these values, then yes, it is a valid input. So we can just say return valid inputs includes input. And we do want to keep that validation though here. So now we can remove all of that. This is a smaller little utility function that just returns true or false based upon whether or not this input is valid. And you could even like take this out because that is not really even specific. Like, I mean, maybe that's used somewhere else. Maybe it's not. For this, we'll keep it in there. But now this really does one thing and that's it. Now down here, get user choice. Here, I'm going to remove that comment. So let's see where we were using get user choice. And I think it might just be this one line. Yes. So now we can say is valid input. So user input, user choice. Now instead of user choice, we could say if it's not valid input, then we throw. And we're looking for this error. So we can say if it's not valid, then throw new error and pass it that string. What's cool too is now like this is just a validation function, right? So we can validate it for the computer too, because like maybe we mess up in a test here or something and we have a typo, we want to make sure that we're actually validating our computer input now too, because, in this case, it's computer input. We could rename these as like player 1, player 2, and player 2 defaults to a computer, something like that. In fact, maybe we should do that. So like player 1 input, and let's just use, then player 2 input. Now, player 2 input happens to be, it'll like default to a computer. But maybe you have maybe you're using this function somewhere else and you actually do want to pass it like two values like this, and you get these two inputs from two separate people or something. So now it's a little bit more versatile. It doesn't necessarily have to be always a one user against one computer, but player 2 defaults to a computer. So now we can say if player 1 input is not valid, go ahead and throw, or if player 2 input is not valid, go ahead and throw. So now we have our validation there. And we can update those variables as well. So now let's run these tests and everything should pass now. Okay, cool, looks good. For the sake of this, I'm going to remove the console logs just because now we have these tests. And now play game is basically just taking two inputs and it's doing some validation, and then we're determining the winner. That's basically what this program is doing now. The next function is get computer choice. Let's look at what this is doing. So it's getting a random number, and then if it's 0, if that random number is 0, it returns rock. If it's 1, it returns paper. If it's 2, it returns scissors. You can pretty much tell that this line of code here is generating a random number between 0 and 2. But I would like this to be a little bit more explicit. So what we can do is we can actually create a utility function. And if this is part of a larger application, this might be like in a utils folder or a utils file or something. But we can create a function called get random number and call this minimum. Let's just call it min and max actually. And max, min, min. So now it's a little bit more clear, okay, this gets a random number between a minimum and a maximum. And so we can replace this and say between 0 and 2. Now this is a little bit more readable and we know exactly what this is doing. And then kind of similar to what we did up here, instead of having a switch statement here, I think a switch statement is a little bit overkill here because basically we're just returning a value based upon an index. So what we can do in that case is do something like, actually, remember how we were saying valid inputs, rock, paper, scissors? Now we can actually literally take that out. We can say random number, return random number, or return valid inputs and pass it a random number. Random number can be actually random index to make it a little bit more clear. And it's going to be either 0, 1, or 2. So 0, 1, or 2. And because we're not passing 3 here, bomb will never show up. So we're safe there. So now we can remove all that. And this becomes much easier to read, I think. So let's go ahead and run these tests again to make sure that we didn't break anything, because that's really something that, as you refactor, you want to be making sure that you're running your unit tests to make sure that you know exactly when you started to break things if you did. But nope, looks like we're still good. The only other function here is determine winner. So let's see what's going on here. User choice, computer choice. Maybe to be consistent, we might call these player 1 input again and player 2. This doesn't really matter, but just to be consistent with the changes we made down here. So let's see. So if player 1 input is bomb, return you won, bomb always wins. I think that's great. If player 1 input equals player 2 input, return the game is a tie. I think that's great. I'm adding little empty lines after if statements. So if player 1 input is equal to rock, if player 2 input is equal to paper, return sorry computer won. Else, return congratulations you won. Since we have a return in our if, we don't really need the else because a return is pretty final. So you can just you can remove the else, and It's just like a little less code, a little like less nesting, I think is always good. So I'm just going to do that for all of these. I think the less brackets and the less nesting, the better. We are duplicating 3 lines of text here for each various scenario. So I'd probably, make these variables probably and say like computer wins message. And then we can swap those out. And then congratulations, you win. So I'm going to say player wins message. Now those only happen once, but just to be consistent, I would probably still create variables for these, just so all of our messages are all next to each other. Now, as we did that, you can maybe start to see how we might be able to refactor this a little bit more, actually. You can see that, like, if this scenario happens, computer win message should be shown. If this happens, same, computer win message, or if this happens. So there's actually 3 scenarios where that happens. So we could probably consolidate those into one single if statement. So what we could say is, did computer win is if player 1 input is rock and player 2 input is paper, or player 1 input, and actually I'm going to put these in parentheses. So that's scenario number 2. And then scenario number 3, okay, so now those are the 3 scenarios where a computer won. Kind of using computer and player 2 like interchangeably, but we could call this player 2 input, or did player 2 win rather. So now we can say if did player 2 win, return computer wins message. And if it didn't, then we know the player won. So now we can get rid of all of this and just return it like that. And now it's really, really readable, right? So like if player 1 input is bomb, return bomb message. If player 1 input is the same as player 2, return tie message. If player 2 won, which is one of these 3 scenarios, return computer wins, else we know the player won. So finally, let's run this one more time and make sure that all of our tests pass. And there we go. We can be confident that like we've changed this code, we've refactored it, and we can be really confident that everything is still working. Now, one last thing that is worth mentioning that you might have noticed is we're doing this input.to lowercase within our isValidInput function, but we're not actually passing that formatted input to determine winner. So what happens is if we had like a test that looks something like this, where we had valid values, but the casing was all messed up, what do you think would happen? So it turns out that it actually passes the input validation because we're formatting that data, but then we pass the unformatted data to determine winner. So let's go ahead and fix that. What we can do is instead of doing our input formatting within our validation function, we should do it beforehand. So up at the top of play game, we can say formatted player 1 input, and we can say formatted player 2 input. And let's create a little helper function called format input, where we get some input and then we return input.to lowercase. Now, the reason that we're creating a little utility function for formatting our input is, in this case, it's pretty straightforward, right? We're just doing to lowercase. But if this got more advanced or more complex, we want a little utility function so that we don't have to duplicate that logic in other places. So we can go ahead and say format input player 1 data, and do the same for our player 2 input. Now what we do is we pass this along everywhere to our validation function and our determine winner function as well. So if we do that, now this test should pass. And it does. Thank you so much for watching. I hope you enjoyed this. I hope you found it useful. And if you like this, I do offer one-on-one coaching, like private calls where we can go over like code reviews, resume reviews, interview practice, anything like that. I also have courses on interview practice. All of the links for that will be in the description below. And yeah, until next time, have a great day. Thank you so much.